Yes, hello everyone. Welcome to our today's topic. We are going to discuss rectilinear propagation and reflection at plane surfaces. So we always encounter light, and light is what enables us to see. The question that we should ask ourselves is that what is light? How is it produced? And its importance. So to start with, you have to define light. So I believe from this lesson, each and everyone will be able to define light. So light is a form of energy that is detected by our eye, making visual perception possible. So light is what enables us to see the objects. Light is what enables you to see me, is what enables me to see you. If it were dark, I would run away. Maybe you are a ghost, or it's about fear. So uh, light throws away fear. So light is very important. Uh, from the definition, enables perception. So the first important enables seeing, that is vision. Light is what the plants use to make their own food. Light enables us to do so many things. Let us move to the sources of light. So sources of light, we have objects that are able to produce their own light. So these objects or these sources are called the luminous sources. For example, the sun. Believe where you are able to see the sun, or if it is at night today, tomorrow you'll see the sun. If it is daytime, you are able to see the sun. Unless you consult, unless if you are not able to see, you can consult the optician or the doctor so that you see. You have the burning candles and many others that you can encounter. We have also the objects that are not capable of producing their own light, but instead reflect light from the sun. These are non-luminous sources, for example, the moon, the planets, the plants, and people, that is you and me. We are not able to produce our light, but we are the one to recognize that other sources are able to produce their own light. If we are not there, then light cannot be produced. Rays and beams of light. So a ray is a path along which light energy travels. In diagrams, rays are represented by lines with arrows on them to show the direction of travel as shown. So these are arrows. Then beams. Beams. So beam is a stream of light energy which is considered to be a bundle of rays, or for in simple terms we call it bundles of rays. So these are the bundles of rays. These are beams. Types of beams. So the first one, you have divergent beams. So these are beams of light that appear to spread out or diverge from a point as shown. So you see sun is the source of light. So it diverges. The light from the sun diverges. Diverge. So it comes from a point. Diverge as shown. Sorry. Parallel beams. Second one, parallel beams. So these are beams that appear perfectly parallel to each other. They can't intercept. That is what is meant by being parallel, meaning you are in parallel, you can't intercept each other. You can't meet. So beams of light from the sun reaching the earth, they are always parallel. They don't intercept each other, but they are parallel, as shown here. So these are parallel beams. Then we have the convergent beams, the last type of beam. So these are beams that appear to collect at a point or converge at a point. To converge means to come together. So they come together. So here is the exercise that you can tackle in class here right away. So we have to define opaque, translucent, and transparent object. So what is an opaque object? So these are objects that do not allow light totally to pass through them, and one is not able to see through them totally. So that is opaque. For example, you are opaque, me, I'm opaque here. Translucent objects, so these are objects that allow light to pass through them, but you cannot see through them clearly. For example, a piece of paper allows light to pass through them, but one cannot see through it clearly. Transparent object, so these are objects that allow light to pass through them and one can see through them clearly. For example, the transparent window panes. Let us now move to the main basic of this, the body of this topic, that is rectilinear propagation of light. So we find that the rectilinear propagation of light is based on the principle that light travels in a straight line. So rectilinear propagation of light is based on the principle that light travels in a straight line. So when light from a source falls on an opaque object, it casts a shadow on the object with a sharp edges on the screen placed behind it. We know that, and we believe, as a believer in light, I believe that light travels in a vacuum, reaching the earth at a speed of 3.0 times 10 raised to power 8 meters per second. How fast is light? So this scenario is always experienced during thunder and lightning. We always hear sound after we've seen the light, but they leave the same place at the same time. So that one confirm that light travels faster than sound. So the speed is 3.0 times 10 raised to power 8. So that is faster. Let us move to the shadows. So shadows are formed when an opaque object is in the path of the beam of light. So the type of shadow form depends on first of all, we have the size of source of light. Second, we have the size of the opaque object, the distance between the object and the light source. So during formation of shadow, we always find that a uniform and total dark shadow is seen on the screen. So this one we call it penumbra. The total shadow sheen is the penumbra. In Latin it is called shade. You can be asked to state the property of light associated with formation of shadow. So this one is based on the principle that light travels in a straight line, which is rectilinear propagation of light. As simple as that. So the shadow has a sharp edge, supporting the idea that light travels in a straight line to confirm the formation of shadows. So the shadow is edged with a border of partial shadow called penumbra. The center of the shadow still receives no light at all from the source. Light from the same parts, so light from some parts of the extended source of light reaches the center part of the shadow on the screen, but light from other parts is cut off by the opaque object, resulting to the partial shadow at the edges. Let us move to the eclipse. So eclipse is a phenomena that occurs. It had occurred before, is still occurring, and it will still occur. So it is a phenomena formed when the rays from the sun are blocked by either the moon or the earth from reaching either the moon or the earth. So it is a phenomena. So the types of eclipse, we have a solar eclipse, also known as the eclipse of the sun. So it is eclipse when the moon passes between the sun and the earth. And when this happens, the moon intercepts light from the sun, thereby casting a shadow on the earth and causing darkness during the day. So here is how it is formed. So you have the sun, the moon. So you have to recognize that the moon, from here you can see that the moon is smaller than the earth. Therefore, we have some partial darkness, and this partial part that is not totally dark, it is called penumbra, represented from the diagram by letter P, and the total dark area is called umbra, represented by letter U. Second, we have annular eclipse. So we find that sometimes the umbra of the moon is not long enough to reach the earth because the distance between the moon and the earth varies. So when the moon is farther away from the earth, its disk is slightly smaller than the sun's disk. So when a solar eclipse occurs, the moon is not large enough to cover the sun totally. So a bright ring of the sunlight can be seen around the edge of the disk of the moon. So that bright ring is what we call the ring eclipse, or what we call the annular eclipse. So it is formed when the moon is farther away from the earth. So the distance is very important. So the distance is farther, meaning it is far from the earth. Here it is how it is formed. So you see where the sun is and where the moon is. See the distance. So it is our special types of solar eclipse, but the moon being farther away from the sun. So we have the total dark area, which is umbra, and the partial dark area, which is penumbra. So this is the ring. So we have the moon too small to hide the sun completely. Then we have the rays, the ring, the rays of the sun forming a ring on this. So it is a ring of sunlight shows around the edge of the moon. Third, we have lunar eclipse. So lunar eclipse occurs when the moon passes through the Earth's umbra as shown. So here is the moon. This is the moon. It passes through the earth. Being that the moon is smaller than the earth, so it must take some time to pass through it. So this is eclipse of the moon. So lunar eclipse, we find that it happens occasionally when moon is full. So that is when it happens. The moon must be full. So that is the condition. Because the moon is small, so it takes some time to pass through the earth. So the time it takes to pass through the earth is 1 hour 45 minutes. Let us now move to magnification. So magnification. So what is magnification? It is the change in the size of an image relative to size of the object. It is denoted by letter M. Also, it is the ratio of image distance to object distance. So the image distance is V, denoted by letter V, and object distance denoted by letter U. Here's the formula that we use: M equals to V divided by U. Also, we can say that magnification is the ratio of image size to the object size. That is, M equals to height of image divided by the height of the object. So we can work out some examples here. So for clear understanding, this is how it should appear. So we have the height of our object, which is this. Then we have the height of image here, object distance, and image distance. So the example is here with us. So the distance between the pinhole and the screen of a pinhole camera is 12 centimeters. The height of the screen is 25 centimeters. Then you are asked, what is the minimum distance from the pinhole? Must a man 1.6 meters tall stand in full length if a full length of image is required? So we have to get the length of the image. So first of all, in physics, we always write the formula. So M equals to HI divided by HO. So from the statement, we have the distance between the pinhole and the screen being 12. So meaning V is 12. Then the height of the screen is 25. So that is the image size, 25. Then the height of the object is 1.6. So you substitute that. Second example, we have an object of height 3 meters is placed 16 meters away from the pinhole camera. Then you are asked, first one, calculate the image if its magnification is 0.01. So you've been given magnification. Then you have the height of object placed 16 meters away. Then you are asked the size of the image. So M equals to height of image divided by height of object. So you substitute that. After recognizing that height of object is 3, you get the height of the image. Then the length of the pinhole. So the length of the pinhole is what we call V. V, you've been given U place 16 meters away. So just substitute, being that the magnification is 0.01. Let us now move to reflection of light. So what is reflection of light? So it is the bouncing off of light. It's the bouncing off of light. The amount of light energy reflected by a body depends on the nature of the surface of the body, and the nature of the surface is either smooth or rough. So the smoother the surface, the greater the fraction of light reflected from the body, and the brighter the body appears to our eyes. We have two types of reflection, that is regular and irregular, or the diffuse. So the regular means we have the smooth surface. So you will see from the diagram that the light are reflected uniformly in the same direction. When you have a rough surface, as shown here, so the light are reflected in different direction as seen. Let us move now to definition of terms used in reflection of light. So let us consider this one. So these are the terms that we want to define. So we have the incident ray, we have the normal line, and the reflected ray. Here is the mirror considered as the smooth surface. Then we have the angle between the normal and the incident ray as the angle of incidence. Then the angle between the normal and the reflected ray is called the angle of reflection. So here are the terms. We have the incident ray is the ray that travel from the source to the reflecting surface. Then the angle of incidence is the angle between the incident ray and the normal. The normal is the line drawn perpendicularly at a point where the incident ray strikes the reflecting surface. The reflected ray is the ray that bounces from the reflecting surface. The angle of reflection is the angle between the reflected ray and the normal. So those are the definition of terms that we use in reflection. So on Earth, we have only two laws of reflection, where the first one is the angle of incidence equals to the angle of reflection. We believe in that. It has been confirmed. Then the second one, the incident ray, the reflected ray, and the normal. We don't say the normal ray. We can say the normal line. So the normal, where we have the incident ray, the reflected ray, and the normal, all lie on the same plane at the point of incidence. Here is a concept that always confuses so many. The rotation of the mirror through an angle. So we find that if the direction of the incident ray remains constant, the angle of rotation of the reflected ray is twice the angle of rotation of the reflected ray. Mark that. The angle of rotation of the reflected ray is twice the angle of rotation of the mirror. So it is as shown here. So here it is. So remember the direction of the incident rays kept constant. Then we have the new reflected ray. So this was the initial. Then we have the new. So you find that the angle is twice the angle of rotation. So this is twice x. The angle of rotation was 10. So it is twice, meaning it is 20 degrees. So these properties, the rotation, is used in instrument where beam of light is used as a pointer. For example, it is used in the mirror galvanometer, used for measuring very small electric currents. And the sextant used in navigation for measuring. Let us discuss this example. Three mirrors. So we have the three mirrors. These are the three mirrors. Are placed at right angles as shown below. A ray of light is incident on one of the mirror. So you can see this is the incident ray. Complete the diagram and find the angle of reflection on each surface. So from here you find that here it is 60 degrees. Being that we obey the laws of reflection, so the angle of incidence here, we have a normal. Normal will be here. So the angle of incidence is 90 minus 60, you get 30 degrees. So meaning the angle of reflection here will be 30 degrees. So this angle here is 60. Then the angle here where this line meets this surface is now 60 degrees. Therefore, when you draw a normal line here, you get this angle here to be 30 degrees. You get this angle here to be 60 degrees. That is angle of incidence, and angle of reflection is also 60 degrees. So when it is reflected here, remember this angle here is now 30 degrees. So this angle here will be 60. So when you draw a normal, the angle of incidence here will be 60 degrees, and the angle of reflection also will be 60 degrees. Then it is reflected now out. The same case there. Characteristics of images formed by plane mirrors. So you can see yourself through a mirror. Then state the properties. Some of the properties are: the image is as far behind the mirror as the object in front of the mirror. The image is the same size as the object. The image is visual, erect, and laterally inverted. The object distance is always equal to the image distance. So let us move to now the images formed by mirrors at an angle. So the formula that we always apply, n, where n is the number of images equivalent to 360 degrees, divide by the angle of inclination of the mirrors. Then you subtract 1. For example, when mirrors are inclined at 45 degrees, you get 360 divided by 45, then you subtract 1. When mirrors are inclined at 60 degrees, so n, where n is the number of images, equals to 360 degrees divided by 60 degrees. Then you subtract 1, you get 5 images. The third one, when mirrors are inclined at 90 degrees, n equivalent to 360 divided by 90 minus 1, you get 3 images. You find that the number of images increases as the angle is reducing. And remember, the angle is the angle of inclination. What about mirrors that are parallel to each other? Meaning the angles between them is 0 degrees. So take any number, divide by 0. Meaning the angle between them is 0. So take any number, divide by 0. So what do you get? You get a math error. So meaning you get a larger number. So when two mirrors are parallel to each other, the number of images are so many that you cannot count. So it is infinite. The symbol for infinity is that. So here are some examples. At what angle will the two mirrors be inclined to form 17 images? So from the formula, we get n equivalent to 360 degrees divided by the angle, which is theta, minus 1. So for us to get the angle, first of all, take this minus the other side. So it will be 17 plus 1, you get 18. So theta will be equal to 360 divided by 18. You get 20 degrees. The same case here, 29. You add 1, you get 30. So theta will be 360 divided by 30. You get 12 degrees. Example 2. How many images will be seen from two mirrors when reflecting surface make an angle of 60 degrees with each other? So this one we had tackled there. So n equivalent to 360 divided by theta divided by 1 minus 1. So it is 360 degrees divided by 60 degrees minus 1. You get 6 minus 1, you get 5 images. Lastly, the applications of plane mirrors. So we have the kaleidoscope. Kaleidoscopes are is just having mirrors inclined at angles telling us the number of images that are formed, as simple as that. So it is just mirrors inclined at angle telling us the number of images that are formed, the way we have discussed. Then the periscope. So periscope, this is an instrument used to view object over the obstacles. It is used in submarines and also watch over the heads of crowds. So the images seen with the aid of instruments are erect and virtual. So we find that in construction, the plane mirrors are inclined at 45 degrees. So this is the angle, very important. It is inclined at 45 degrees to the horizontal as shown in the figure. So as shown, so that is the periscope. So you find when the object is there at the corner where you cannot view it, you just place your periscope so it is reflected and you see the image is erect of that object.